Conceptually, we can think of a Blackboard just like a class that has values that we can read and write to. This is convenient when we're talking about things like the animator or a behavior tree, because we have a lot of little components of that may need to read those values and may also need to write to those values. Today, we're going to take a look at Unity Behavior's Blackboard and how we can write values to that Blackboard from our scripts. This is a very important thing for us to do when we're creating AI, because we need to inform the AI or the behavior tree about the world and about things that are going on, so it can start making informed decisions that look intelligent. The I in AI. Hey, Chris here from LlamAcademy. Here to help you. Ooh, me? Yes, you! Make your game dev dream become a reality by helping you use a Blackboard to make your AI even smarter. Unity Behavior makes it very easy for us to set these values. In fact, it's just graph_agent.setVariableValue, and then we tell it which value we want to set and the value we want to set it to. There are some limitations with Unity Behavior's Blackboard, and since it seems like Unity is not going to invest more in that, it's important to take note of this. First, there are a limited set of types that we can put here. We can put any primitive type. We can put structs like vector3, vector3int, vector2, all of those standard Unity types work as well. And we have some list types that we can use. Enums are fine. We can even use our own custom enums. But if we want to put our own C# classes, they must derive from Unity Engine Object, which means mono behavior types and scriptable object types are both fine. But if you have just a plain old C# class, that cannot be added to the Blackboard today. There are event types, and we can create our own event types right here in the editor, and those are fine and can be added easily to the Blackboard. In short, if it's a Unity type, it can probably be added to the Blackboard. If it's your own custom C# class that does not derive from Unity Engine Object, it cannot be added to the Blackboard. Now, as usual for this little mini series, I'm going to be using the Unity Behavior sample, which we can get to by going to the package manager, finding Unity Behavior, going to samples, and clicking import. I've made a small modification here to add a UI that we'll use to set those variable values on the Blackboard. Let's take a look. In our assets, samples, behavior, version, Unity Behavior example, we have this example behavior graph. In this graph, we have a Blackboard with some variables already here. A self, a target, and a speed. We can already see in this example the usefulness of the Blackboard. This node, setRandomTarget from tag targets, assigns the value target, which is a game object, to a random object in the scene that has the tag targets. Then later, we use that same game object, target, and make it say something, and then move this game object, the self, to that target game object. So already we're seeing when nodes need values, we pull them from the Blackboard and we can override them and change them based on some logic in our graph. Speed, we don't see anywhere, but if we select the self navigates to target and open up the inspector, here we can see that the speed is hooked up to the speed variable in the inspector. So if we set a high speed value, the self will move to this target much faster. If I come over to the game view and find the behavior agent, we can see both the agent and the speed, but not the target. That's because when we select the target in the Blackboard, it is not exposed. If we click that, we'll see that that target then shows up. By not exposing it, that makes it effectively an internal variable that we wouldn't expect an external thing to set, because we can override or set default values per agent right here in the inspector. In fact, if we just duplicate this agent and set the speed override to 1 and click play, we'll see that second one moves much slower. So even though these two are using the same behavior graph, they're doing stuff slightly differently based on these Blackboard variables. Now, because that's a lot going on, let's delete that second agent. And I've created a UI, and we'll take a look at the code for that in just a second. But what it does is sets some variable values on a target agent. So I've hooked up that behavior agent that it should control. And as we update the speed and we update this should move and update the thinking text, we'll see the agent behave differently. But first, we need to add those to the Blackboard. So on that example behavior graph, I'll add a new Boolean called should move and a new string called question. We'll overwrite this first question about what should I do with the question just by dragging it right there. And we can even set a default value like what should I do? Then instead of doing this random, I want to control whether we will let me think about it or move based on the should move Boolean. I can add a conditional branch, assign a condition, a variable comparison, and say should move is equal to true. If so, we'll do that right one. If not, we'll do this left one. And now that this looks like a strange octopus, we can auto-arrange it by selecting that on start node and pressing Shift A. If this is going a little bit fast for you, I have several other videos in the series where we break down the control flow nodes and an introduction to Unity behavior. I'll have links to those in the description. Now we'll keep this agent selected and click play so we can see those Blackboard variables. First, we'll see that all of these get overridden and they're set from what we see on the UI. So if we increase the speed, we see over here in the inspector, that speed has changed to the same value. If we change the thinking text to something like, who am I? Now he says, who am I? Instead of, what should I do? We can change it back and turn on should move. And we'll see very quickly it responds, the agent decides to move, and he moves very quickly because the speed is now 5.4. And we can change it in real time and it responds to that speed. That's because the nodes that are using these Blackboard variables are reading them in real time from that Blackboard. Now let's take a look at how we can set these in code. I created a very simple Runtime UI model behavior that's attached to a UI document. That's the UI toolkit UI, where we see the slider, text field, and the toggle. We also have that serialized field private behavior graph agent, behavior agent, that we are going to be manipulating the Blackboard of. We have a little bit of boilerplate here. I've registered some change events, so we'll set those Blackboard variables whenever those values change on the slider, toggle, and text field. And down here at the bottom of awake, we see the magic sauce here, that behavior graph agent dot set variable value, and then just that variable that we want to set the value of, and then the value we want to set it to. That then makes it very easy for us whenever these sliders, toggles, and text fields change to do the exact same thing. Whenever the thinking text has changed, we set the question on the Blackboard to be the new value, and the same process for the toggle change and when the slider value changes. So we can do this in response to anything that happens in the game. In this video, we just are happening to do it based on the UI. Now, if in your code you need to read some value from the Blackboard, it works very similarly. We do behavior agent.getVariable and then provide the variable name, and we'll get out a Blackboard variable of that variable type. A Blackboard variable is a thin wrapper around a type that gives us some extra functionality that we'll take a look at in just a second. And we can give that a name like question variable. And it's important that we wrap that with an if, because if this returns false, that means that that variable doesn't exist with the type that we expected. So anytime we want to get a variable, we want to wrap that with if, and then get the variable, get a reference to the Blackboard variable. And in this case, we can do something like debug.log, the current question text is, and then just do plus the question variable, because Blackboard variables can be implicitly converted to their type. But if we want to access that value directly, we can do .value. One last cool thing we can do is we can listen for changes on these variables and do something in response. So we can do something like question variable.onValueChanged, and this is just a delegate. So we can do plus equals any function we'd like. In this case, I'm going to just do an inline function to debug.log the question variable value has changed. If we leave this like this, we might end up getting an error because the order in which our scripts are initialized is not guaranteed, and the behavior graph agent has to do some stuff on awake. So if you ever want to set variable values or get variable values, I recommend you do that on start. If we come back to Unity and click play, we can see all of this in action. We can see that we get that the current question text is what should I do, which is exactly what we'd expect. If we then change the thinking text, because the change callback on a text field is raised when each character has changed, we get a bunch of logs for the question variable value changed, which is exactly what we would expect to see. I hope this video has helped you understand the Blackboard in Unity behavior and how you can set values on it at runtime from your own code. This is extremely important for us to understand when we're making our own AI, because we always need some way to take the world and pipe it into our behavior system, be it Unity behavior, scope, or even a state machine. And the Blackboard is a great way to have those pieces of data that we need for our AI encapsulated in a single place. If you got value out of this video or the series, make sure you've liked and subscribed, and share this out with a friend who would also get value. And yes, I still have 2 big projects I can't wait to share with you that are coming very soon. If you want to show your support for this channel, you can get yourself some LlamAcademy merch right here on YouTube. You can use the affiliate links down in the description to do your Humble Bundle or your Unity Asset Store shopping. You can check out my shader graph course, or you can become a YouTube member or Patreon supporter. Your recurring contribution there helps me out tremendously. If you do that, you'll get access to a private members exclusive Discord, as well as get your name up here at the end of every video and in every GitHub repository that comes out while you're a supporter. And of course, starting at the awesome tier, you'll get a shout out like these awesome folks: Ivan, Iphiobulus, Jason Hansen, Angel, Snedden, Trey Briggs, Will B, Mustafa, Nick5454, and Pixel Wizards. And of course, there's also all of these great supporters as well. Thank you all for your support, and I'll see you on the next video.